Okay, so let's just take a look at the warm-up for today. The first one, all I'm asking for you to do is just to expand. So how do we expand out 3 to the power of 6? Well, that's just 3 times 3 times 3 times 3 times 3 times 3. Okay, that's it. Over 3 to the power of 4, 3 times 3 times 3 times 3. That's it. Okay, let's just stop there. We'll just expand and stop right there. The next one, I'm asking you to simplify this. So yes, you do somewhat need to solve it. What's the first thing you want to take care of? Hopefully you said these negative exponents. How do we get rid of the negative exponents? Well, the negative exponent rule says that if we have an exponent that's negative, we just kind of swap the places here, and it will turn it into positive. So let me caution you. This -3, what base is it attached to? Is it attached to the 4? You're correct, it's not. So do not touch the 4. The 4 is still staying in the numerator. Okay, so the 6, same thing with that -7, still staying in the denominator. So instead, we are going to move that x to the -3 from the numerator to the denominator, and then the y to from the -7 from the denominator to the numerator. Now you are not finished yet. Simplify. You need to simplify these coefficients. Can you simplify 4 over 6? Yes, you can. Simplifies to 2 over 3. Y to the 7th, x to the 3rd. So today we're going to take a look at the quotient of powers exponent rule. This is dividing exponents. Okay? What the quotient of power says is if the dividend and the divisor have the same base, you can simplify by subtracting the exponents. Okay? This is the rule, the formula that you are going to see. It is available on your star chart. Look here, same base. Okay? So the rule says if the base is the same and we are dividing, we are simply subtracting those exponents. Okay? So let's take a look at an example problem here. I have x to the 12th over x to the 7th. Okay? I can use my quotient of powers rule. Rule says same base. I have base of x. And must subtract my exponents, 12 minus 7. Okay? So what does that reduce to? I have x to the 5th. And that's our answer. Okay? So let's take a look at these problems. Forgive me here, I do not know what happened, but this should be a dividing sign. Okay? So we have b to the 25th power divided by b to the 5th. If visually, it makes sense to write this out like this. Go for it. Do it, okay? If you can see it better this way, go for it. Okay? So now we're going to use the quotient of powers rule. Same base. What's my base? Well, you got it. My base is b, okay? Same base. So quotient of powers rule says same base, my b, and I'm going to subtract my exponents. So I have my b, 25, minus 5, and that simplifies down to b to the 20th power. And that is my final answer. Okay, let's look at the next one. Don't panic. I know that there's a fraction and an exponent, but you got this. Okay? Still here, quotient of power rules, bases are the same. Have my x, and I'm going to subtract my exponents. 5/2 minus 2. If you have to, put it into Desmos, but do not give me a decimal in the exponent position. Okay, if you receive a fraction, please put it as a fraction. So when I reduce this, I have x, right? Let's take a look. 5/2 minus 2. Okay. Would you agree that 2 is the same as if I wrote 4/2? You're right, it should. You should be agreeing. And so now we can subtract those. Okay, if you didn't want to put it in Desmos, now you got this. What is 5/2 minus 4/2? X to the 1/2. And for now, we're going to leave this as is. Okay, that is your answer. On this problem, we're still using the quotient rule. Okay, let's look at our base m. I have m, 2 minus 5. And then I'll look at my base n, 4 minus 3. And I'll simplify. So my m power, 2 minus 5, is -3. My n power, 4 minus 3, is 1. You do not need to put that exponent of 1. Okay? Now, do not leave your answer this way. What is wrong? Are you thinking to yourself, oh, we have this negative exponent? You're correct. Okay? We never want to see a negative exponent in our answer. So to make that exponent positive, we're going to flip the location. Okay? So n is remaining where it is. And instead we have m to the 3rd on the bottom, and that is our final answer. Now let's look at this next problem. So the first thing I'm going to do is I'm going to make this easy for me. I want to reduce my coefficients. So 12/15, what can this be reduced to? Okay, so I'm thinking 4/5. Yes, okay. Now, still within the parentheses, let's take care and do our quotient rule. So here, same base p. I have 3/2 minus p. And remember, this exponent here is 1. Okay, so I have an exponent of 3/2 minus 1. What is 3/2 minus 1? Did you say a half? Perfect. So that p is on top. Here's my 1/2. Okay. Still, everything is raised to that 4th power. Now, what am I going to do? From here, I'm going to use my power to a power rule. Remember, now this 4 is on the outside of the parentheses. So we're going to distribute it to everything inside these parentheses. And when we do that, we're multiplying. Okay? So if I expand, I have 4 to the power of 4. And p, what is 1/2 times 4? Remember the product of power rules? It says we multiply. Well, that's p to the 2nd. And in our denominator, I have 5 to the power of 4. Now I'm going to simplify. So my 4 to the 4th power is 256 p squared, because I cannot simplify that anymore. And then 5 to the 4th power, so we have 5 times 5 times 5 times 5. Put it in Desmos if you need to. 625. And that is my final answer.